What is up, everyone? We are at 5.10 for AP Chemistry. This is on multi-step reaction energy profiles. So we covered the energy diagram in an earlier section. An energy diagram is something that looks like this. And we can determine if it's endothermic or exothermic depending on whether we decrease in energy, that means energy had to have been released, or if we have something that looks like this, that means energy increased and I had to add energy to do it. But we've also discussed in recent sections that not every reaction happens in one step. So we know that there could be multiple steps. And so this section is looking at how do those energy diagrams look if there's multiple steps. So our reaction profile is going to look very similar. The difference is you will have a peak, if you will, for each step for the reaction. So if I have a two-step reaction, I would have two peaks or two transition steps. If I had a three-step mechanism, I would have three peaks or three transition states. Remember, the rate determining step is going to be the highest activation energy. High activation energy means the reaction happens really slow, and low activation energies means that it happens really fast. The valleys in between peaks are where we have intermediates. So let's look at a few examples of what this might look like. In example number 1, we have a potential energy diagram, and overall the reaction is endothermic. And I can see that because I'm starting, and I'm going to use a different color here. I'm starting at a lower energy and I'm ending at a higher energy for my product. So that means that overall the energy had to increase, which means that I had to put energy in, which means delta H is going to be positive, which means that this is an endothermic reaction. The first step is also endothermic because I'm starting low and ending at a high where the intermediate is. The first step would also be considered my rate determining step. And the reason that it's my rate determining step is because if I compare the activation energies of each one, for step 1, my activation energy is going to be represented from this line. So remember, activation energy is from where I started to the top. For step 2, though, that's a much lower activation energy. So from the start of step 2 to the peak is a much smaller incline than it is on step 1. So that tells me that step 1 has to be the rate determining step because it has the highest activation energy. Final thing I want to point out in this example of a two-step mechanism is that the second step is going to be exothermic. If I just zoom in on the second step, I start here where the intermediate is and I end at a lower energy for the products. So for the second step, I'm going to have an exothermic step. The first step was endothermic, but overall, my net is going to be endothermic. We can also use information that's given to us to try and construct a diagram. So here in this example, we have a two-step mechanism that says step 1 is our slow step and that it's endothermic and it's 90 kilojoules per mole. And then step 2 is going to be exothermic and it's going to be my fast. Now, how I can tell whether it's endothermic or exothermic is by looking at the sign for delta H. Remember, if it's positive, that's going to be endo. And if it's negative, that means it's going to be exothermic. So if I want to know overall, then I'm going to simply add these delta H's together. And if I do, I get the delta H for the whole reaction as being negative 10 kilojoules per mole. The first step is going to be my rate limiting step. So if I was going to draw that, I would make sure that I have the first step having a higher activation energy because it's the slow step. And my step 2 is going to have a smaller activation energy. I also want to make sure that I show my first step being endothermic. I'm putting energy in. And that my second step is exothermic. And then overall, I want to show an exothermic reaction. So my reactants are going to be higher than my products are. So occasionally, they would give us this information here in the reaction and ask us to construct a graph that would match the information that's given. Okay, so use the reaction potential energy profile to answer the following questions. How many elementary steps are involved in the reaction to the right? I see 2 peaks, so that means that there are 2 elementary steps. And I know this because there are 2 transition states. There are 2 peaks, which are also known as transition states. Which step would be faster? And so remember, the quickness or the rate of each step is dependent upon that activation energy. So if I compare the activation energy for step 1 versus the activation energy for step 2, I can see that this activation energy for step 1 is much bigger than the activation energy for step 2. So I would say remember, a fast step means lower activation energy. So that means that step 2 would be faster. And the reason I know that is because it has a lower activation energy. Second example they want us to construct what this might look like. So it says the following is a sequence of elementary steps for a proposed mechanism. And we have 3 steps, so that means that I'm going to have 3 peaks. It tells me that step 1 and step 2 are fast, and that step 1 and 3 are fast, but step 2 is slow, so that means it's going to have the highest activation energy. And they want us to construct what this might look like. So it says to include the following details: include the relative activation energies and the change of enthalpy if the overall reaction is endothermic. So I don't know individual information about each step, and so that makes this just slightly tricky. But given what they have told me, I can construct the following. I would start here with my reactants. See if I can draw that better. And it says that the overall reaction is going to be endothermic. So if this is my reactants, that means that I'm going to make my products end higher. I don't know why I wrote higher. I meant to write products. So that shows an overall increase in energy, which means the reaction had to absorb energy to happen. Now, I need to show 3 peaks with my highest activation energy in step 2. So this is where it's going to be a little bit tricky. So I'm going to make a small activation energy for step 1, and then I need to have the biggest activation energy for step 2, and then a relatively small one for step 3. So I might have it look something like this. Again, I just want to emphasize that if they had given me more information, I could have provided more details as far as like if step 1 was endothermic or step 2 was exothermic or anything like that. But they didn't tell me that, so I can only construct my graph based on what they did give me. So I want to just make sure that my second step, step 2, has the highest activation energy compared to step 1 and step 3. And I think I've illustrated that. Again, I cannot stress this enough. If they had told me more information about each step being endothermic or exothermic, I would have included that in my graph. But since they didn't, I showed what I could. All right, that is it for 510. One more section to go. I'll see y'all next time.